Right, so it gives us a diagram and it tells us the equation of a circle. Now it doesn't give us the equation in the standard form, and it then asks us for the coordinates of the centre and to show that the radius is 5. What we're going to have to do is to rearrange the equation of the circle that they give us so we can get it into the form that I've written here in red. Because if we get it in this form with x minus a in brackets all squared plus y minus b in brackets all squared equals r squared, we can just read from that equation straight away what the centre is and what the radius will be. You know, you can see that the number which we subtract from x before squaring it is the x coordinate of the centre, and likewise the number we subtract from y will give us the y coordinate of the centre. So how do we get from the equation they give us, which is x squared plus y squared minus 20x minus 16y plus 139 equals 0. All we have to do is do a process of completing the square. Now first I would get the x's together, so x squared minus 20x plus y squared minus 16y equals, and then 139, I suppose we can move on to the other side. Right. Now, x squared minus 20x, if we halve the coefficient of x, we get x minus 10. Square the brackets like that. That's going to give us our x squared minus 2 lots of 10x, or in other words minus 20x. It's also going to give us a minus 10 squared, or a plus 100, which we don't want, so we're going to have to subtract 100. And then likewise we halve the 16, we get y minus 8 squared, but then we need to subtract 64 equals 139. And what we've got now is x minus 10 squared plus y minus 8 squared equals 164. That should be a minus there, sorry. 164 minus 139, which comes to, I think, 25, which is the same as 5 squared. So we can now say that the coordinates of the centre are 10, 8, and the radius is the square root of 25, or in other words 5. Radius equals 5. Okay, and really we've shown that by showing that x minus 10 squared plus y minus 8 squared equals 5 squared. That's good enough to show that the radius equals 5. Right, next thing, it tells us that the line L has got equation x equals 13, and it's shown it on the diagram. We've got to find the y coordinates of P and Q. So here's P, here's Q, and it wants us to kind of work out y coordinates of these two. The line there is the line x equals 13. So L is the line x equals 13, right? So both of these coordinates here, P and Q, both have x values of 13. And what we're going to have to do is to try and work out what the y values are. So if I call the top one yp and the bottom one yq. Right, all we're going to have to do is, that's yp and that's yq. All we're going to have to do is to substitute x equals 13 into our equation and then solve it to find the two possible values for y. Okay, so nothing too hard. So if we substitute in x is 13, we get 13 minus 10 squared plus y minus 8 squared equals 25. 30 minus 10 of course is 3 squared is 9, so y minus 8 squared equals 25 minus 9, of course, which is 16, and that tells us that y minus 8 is plus or minus the root of 16, or in other words plus or minus 4. So that means we've almost done it. That means that for yp, where we want the y value to be higher, we use the plus 4. So we're going to have plus 4 plus 8, which is 12, and for yq, where we want the y value to be lower, we're going to use minus 4, and minus 4 plus 8 equals 4. And there we have it.